This video will be discussing probability using regarding to union and intersection. You remember union and intersection concept is the concept we already cover in the first chapter of the course, right? And let's say in this video we use those concepts to solve a probability problem. Okay, so let's get started. So I'm gonna put over here the title here. I'm gonna put probability. Again, probability. With union and intersection. Okay. So this type of probability here, we call that the compound probability. So if you has a chance to take an intermediate algebra course, when we talk about compound inequality is an inequality using intersection and union to connect inequality to each other. So compound probability is a probability regarding to the union and intersection. Okay, probability. Okay. Now let's talk about the union probability first. Or sometimes we call that the all probability. Union probability. And in this union probability, there are two different types of union probability. The first type we call that the probability with mutually exclusive event. Okay, probability with mutually exclusive event. So let me explain the word over here. Mutually exclusive event, it means that two events they are exclusive from each other. It means they don't have anything in common between each other. Okay. On the second type, we will have probability with non-mutually exclusive. So exclusive, it means that's not included inside each other. That's what it means. Now we're gonna jump to the first example. Then you can see easily. But the formula to find this type of probability as follow. So the probability of the first event A union event B, this is equal to probability of A plus probability of event B. Okay, so this is the formula. And again, event A and B, event B here has nothing in common between those two events. Okay, or sometimes the word over here I can write is a probability of A union B. Okay, now let's start with our first example. Let's see. So I have the problem like this. Okay, I should delete this, but that's okay. So I'm gonna go ahead and just delete this. Okay, Alright. So I'm gonna put this as the first example. Example number 1. Okay. Alright, answer. Now let's see how we're gonna do this with this problem. So we run a single six side die. Okay, what is the probability of getting either 4 or 5? Now, so first of all, we need to recognize two events over here. The first event is getting 4, and the second event is getting 5. And these two events, they are independent of each other, right? They don't have anything in common, because there's no way you're gonna roll a dice and you will come up with 4 and 5 at the same time. No way, right? So these two events here, they're independent of each other. There's nothing in common, so that's why they call it exclusive, mutually exclusive. They has nothing in common. So we know. So the probability of getting 4 or 5. So getting 4 is event A, and getting 5 is event B. So we can find this probability of 4 or 5. Will be what? Will be a probability of getting 4 will be 1/6, right? Because of 6 phase. And you want to add it to the probability of the 5 will be 1/6 also. So the answer will be, so the answer over here will be 2/6. So it will be 1/3. Okay. So that's the probability. None of them is related to each other. Okay. Okay. Let's see. I can give you another example here. How about let's I try to create another example. Let's say let's say, okay, so what if I have something like this? Example number 2. So I have a bag. Bags contain 10 marble, 10 marble with different color. Okay, so let's say the first color is red marble, blue, yellow, green, white, black. 1, 2, 3, 4, 5, 6. So I need 4 more color. Red, yeah, purple, brown. 1, 2, 3, 4, 5, 6, 7, 8. Purple, brown, gray. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. I need another color. Orange. Okay. There you go. Okay. So I have a bag, and inside the bag it contains that 10 different colorful marble like that. Okay. Okay. Now the question is, what is probability of getting blue or orange marble? Okay. Okay, so you know that the blue and orange marble, it cannot be mixed up. We don't have any marble that has blue and orange at the same time, so they are exclusive event. Okay, so we can solve this easily. So the probability of blue or orange will be probability of getting the blue marble plus probability of getting the orange marble. So you have only one blue, so 1 over 10, and you have another 1 over 1 over 10. Okay, right? Okay, so this give you 2 over 10, which is 1 over 5. There you go. See that? All right. Now the second type of probability, union probability, is the one with the non-mutually exclusive. Okay. Probability with mutually inclusive, or you can say that non-mutually exclusive event, or you can say mutually inclusive event. It's the same thing. So it means that in these two events, they have something in common. For example, I have this. Let's say, what if I have this one here? Alright, so I have problem like that, and I have a picture. Let's see, where's my picture? Okay. Okay. So let's see how we do this. So we have 52 car, and as you see, show in the figure, so 52 of them. Okay. I don't. This picture over here didn't show everything. I don't have the picture of that one. Actually, I don't know if I have it or not. I think I deleted that already. Yeah, some way somehow I deleted, so it's not over here anymore. Okay, so we know the card deck. If you watch the previous lecture video, you know that what is the 52 color block. Suppose that these cards are shuffled and you random select one card from the deck, and what is the probability is like a diamond or the picture. Okay, all right. Now for the mutually inclusive event, okay, you have to use the different formula. So I guess I'm gonna go ahead and pull this down a little bit here. I need to provide you the formula first. Okay. Okay. Okay, so the formula, it kind of look like that. So we have two probability A union B. It's also the probability of A plus probability of B, but because two events over here, they have part in common, so you have to subtract the probability of A and B. Okay, A and B. So this is the formula we use to calculate. Okay. All right, then now in the first example, we will do this one. Okay. All right, let's see how we do this. And let's say two events, they have something in common. So what is the probability of silicon diamond or a picture car? Now, if you notice, the picture car, Jack, King, and Queen, you see Jack, King, and Queen, it could have diamond shape inside. So two event diamond have Jack, diamond and Jack, King, Queen, the picture car, they share something in common. They both they on the same card, right? Jack, King, Queen. They have they have diamond also, so they share something in common. So the first thing we gotta do is we gotta calculate the probability of getting a diamond for us, right? So in this case, we'd have probability of A union B with probability of getting the diamond. So how many diamonds we have? So we have totally so we have 13 cards for each shape. So we have 13 over 52. So we have 13 diamond in the card deck, right? Then how many Jack, King, and Queen? There are four different shape, right? So we have diamond, we have heart, we have club, all right. Then we have spade. So they have four of them, and each of them has Jack, King, and Queen. So totally we have we have 13 also. Oh no, we have only 12. I'm sorry, miscounted. So we have only 12 Jack, King, and Queen for four different shape over here. Oh, 52. Okay, so this is the probability of getting a picture card. Then you have to subtract the probability of having diamond and picture card at the same time, which is just 3 over 52. And now you see that you can calculate them, which is give you 25. 25 minus 3 is 22 over 52. Which is 11 over 16, which is you see that less than 1. Now, okay. Okay. So this is like mutually inclusive. Is that they include in each other. Now let's how about this one? Example number 2. What if I have this? Let's say what if I have 1, 2. Okay, how about this one right here? Okay. Let's say this is inclusive or not. So we have a group of 50 students, 23 of them like math, 11 of them take psychology, and 7 do math and psychology. See that they have 7 doing both math and psychology. So uh, this is the inclusive right here. So the probability is to be very easy. So the probability of a student taking math or psi will be probability of student taking math, which is 23 over 52, plus probability of taking the psychology, so 11 over 50, just 50, not 52. Then you subtract 7 of them over 50. So you're gonna end up with which one? So we have 23 plus 11 is 34. 34 27 over 50. Okay, so if you go ahead and put it into the calculator, then you can calculate the percentage. Okay, example number 3. Okay. What if I have this here? Okay, so it's using the figure, so I need to load the figure also. So the figure here. So use the figure to find the probability. On the pointer, we stop on an odd number or a number less than 5. Now we gotta check if it is inclusive or not. So an odd number and a number less than 5. A number less than 5, it has odd because the odd is 1 and 3. So they do have something in common. So in order to do this, very easy. So probability of two event odd or number less than 5 will be probability of the odd first. So how many odd over here? You have 1, 2, 3, 4. 4 over 8 plus probability of number less than 5. So 1, 2, 3, 4. 4 over 8 also. Less than 5, we have 6, 7, 8, or 6, 7, 8. There's only 3 of them. 3 over 8. And we subtract the number that odd and then less than 5, so it's only 1 and 3, so it will be 2 over 8. So you're gonna end up with 7, so we 5 over 8. That's the probability. Did they calculate wrong over here? How many odd number we have here? 1, 3, 5, 7, so 4 over 8. A number less than 5 is 1, 2, 3, 4. So this is 4. This is wrong right here. So there's a 4 of them. So it will be 10. So this will be 10 over here. So 10 over 8 will be 5 over 4. Oh, this is 6. I'm sorry. I feel sleepy now. Maybe that's the reason. 6 over 8 should be 3 over 4. Okay. All right. Let's see if we can do another one. Example. This example number 4. Okay. So we need to load the table also. Data. Right here. Okay. Okay. Example number 4. So if one person is randomly selected from the population represented in the table, find the probability the person is male or female, So Mary and female, you see that it says something, they could be Mary and female at the same time. So I can do a easily probability of Mary or female, because female could be Mary, Mary could be female, so they have something in common. So probability of the Mary first, we have 137 over 264. Yeah. And over here we have this plus a female. Mary female is 69. Oh no. Mary is 137 over here. No, female, a female is not 69. Female is 136 over 264. But they could be male and female at the same time. Mary VS will be minus 69 over 264. Okay, so over here, go ahead and put into the calculator. So we have 137. Patient with me, okay? 137, but 136 minus 69 give you 204 over 264. You gotta simplify that. 264. Around 17 over 22. I have to use calculator. It's check faster. B. A person is divorced and widow. Divorced and widow. Divorced or widow. So we see that there's none of the female or male who's divorced or widow and widow at the same time. So there's nothing common. So over here you just this is exclusive event, divorce or widow. So there's two separate ones. So you're gonna have divorce. You can have 26 over 264. And widow is 14 over 264. So you're gonna have 40 over 264, right? Divide 264. So you simplify this, just give you 5 over 33. Okay, good. Okay. All right. So that is the union probability. Okay. Now we're gonna jump into the second type. We call that intersection probability. Okay. So I'm gonna put the second Roman here. Intersection. For the intersection probability, we also have two different types. The first type we call that independent event. Okay, so we have probability with independent event. So there's nothing. It's not depend on each other. So you know the intersection you mean and. So we have the formula that is the probability of A and B. We can write probability of A intersect B. So it will be probability of A times probability of B. Okay. Alright, so now let's start with our example. So none of them, this is an independent event. So independent, the independent event, it means the probability, the occurrence, that's what I mean, the occurrence of the first event has no effect on the probability of the other. Okay, let me repeat it. Independent event is mean that the occurrence of either of them, the first event or the second, has no effect on the probability of each other. Has no effect on the probability of each other. Okay. For example, I have something like this. Let's say how about this one right here? Okay. So I have a problem like this. Let's use different color here. Okay. So we have roulette, and we have 38 slot. We have total 38 compartment, 18 the black, 18 the red, 2 are green. Okay. Equal the property of 38 number. Find the property occurs on 2 consecutive play. Find the property of let's say of the black. Okay. Occurring on 2 consecutive play. Okay, so if in the first play you have black, and you see it's not gonna affect the second performance for the second play, right? Because the second play could be black also, so it's not affecting each other. So in order to do this, so you're gonna calculate the probability of black. Okay, and of black. Yeah, so this is give you the probability of the black times the probability of the black. So the probability of the black is we have 18 black over 38 times 18 over 38. Okay, because it's you see that it's not gonna affect it because this even though you got the first black, okay, you still have under the second event for the second performance you still have 38 slot, so it's not gonna affect anything. Okay, it's not gonna affect anything. You still have 18 black in the roulette. This you're not gonna, you did not lose any compartment, any black compartment after the first performance, right? So that's why we call that independent. So from here, you're gonna end up with 9 over 19 times 9 over 19. Then you're gonna have 81 over 361. Okay. Example 2. Okay. How about this one? Find the probability of having 4 boys in a row. Okay. Probability of having 4 boys in a row. So either you have boy or girl. So the first row, second, 3, and 4. So the probability of getting the boy is a half, right? The probability of 4 boy first boy, 4 boy. I hope I can close this. 4 boy. So the probability 4 boys in the row. So for the first boy, you have only 50% because you either have boy or girl. And the second one, 1/2 again. The third one is 1/2. So 1/2. So you're gonna have 1/16. Okay. They are independent from each other because even though the first one is girl, the second one is not gonna affect by the first one. If the first one is boy, the second one it could be boy also. So it's not gonna affect each in terms of probability. So that is independent. Okay. Example number 3. If we have this. Okay, answer. This one is kinda, you need to think a little bit over here. Okay. Okay, you want to find a probability that South Florida will hit by hurricane in 4 consecutive years. So we know the probability for 1 year is for any single year hit by hurricane is 5/19. Then from here we can find the probability for 4 consecutive years. So the first year it could be 5/19, and you see that the second year is not affected by the first one, right? So the weather on the second year is not depending on the weather of the first year. So that's why the probability is not dependent on the first year. So on the first year you still have this. And on the fifth one you still have this and this. Then you're gonna end up with 25 times 25 is 625, 19 raised to the 4 with 13032 1. Okay. So if you do the division, it's kind of small. There's only 0.000479, so it's about 0.4%. It's not a lot. Okay. B. What is the probability that we will not hit by the hurricane in the next 4 years? So we know that this is hit by hurricane in 4 years. So the probability is not hit by hurricane in 4 years will be P prime will be 1 minus P. So it will be 1 minus 0.00479. So you're gonna end up with the probability is 0.995 Okay. Oh, let me see. I think something wrong. What is the probability it's not hit by a hurricane? So we know it's not hit by her. So we need to do hit by, not hit by in the next 4 years. What is the probability? So not hit by hurricane in the next 4 years. So we're gonna do 1 minus the probability in the next 4 probability of getting hit in the next 4 year. So first of all, we need to find. Oh, I think something wrong. I think we need to think a little bit over here. So the probability is not hit in the next 4 years. So we need to find the probability not hit in 1 year first. Okay. So the probability for a single year is this. So the probability for hurricane not hitting in 1 year will be 1 minus 519. Yeah. So over here, you're gonna end up with what's wrong with this? Oh. So you're gonna end up with 14 over 19. Okay. Then the probability not hit in the next 4 year. This is not hit it in 1 year. So probability of not hit in the next 4 year will be P 4 year will be 14 over 19 times 14 over 19 times 14 over 19 times 14 over 19. Then you're gonna end up with like 14 over 19 raised to the 4 power. Go ahead and calculate it for yourself. Okay. And for part C, well, what is the probability that I'll hit by hurricane? At least 1 in the next 4 years. At least 1 in the next 4 years. So we have a probability not hit in the next 4 years. That now we need at least 1. So part C, at least 1 in the next 4 years. For 4 years. This is a probability of not hit in the next 4 years. At least 1 not hit. So this is 1 minus 1 minus 14 over 19 raised to the 4. So that's what it is. Because this one, we want to find the probability of the hurricane at least hit it in the next 4 years. But we had a probability of not hit it by hurricane in the next 4 years already. Then at least you just do 1 minus. Yeah. Okay. Good. All right. Now, so that's the first type. Now we need to do the probability with dependent event. So dependent event, it means the first the performance, the occurrence of the first event will affecting the probability of the second event. Okay. To probability of dependent event. Okay. Okay, let's do some of it. So we're gonna jump into the example right away. Have something like this. Find the probability of getting two king, first king and the second king. So this is n, and you see two king, the first king, the second king. There's nothing. They is that they depend on each other too? You gotta check, right? Let's see. Answer. So the probability of getting a king and getting two king. Okay. The probability of getting the first king. So how many king we have? We have 4 king of 52. Okay. Then the second king n. So we have 3 out of 51. Alright. Then the answer over here will be 1 over 221. Okay. So it depends. You see that the second event is affected by the first event, because you already got the first king already, and the second king there's only 3 king left, right? So they depend on each other, and you see the first king gone, so that's why we have only 51 cards left. Okay, so number 2. How about this one? Answer. So we have 1 person at a time. Okay. So 3 person are random selected, 1 person at a time, from 5 freshmen, 5 freshmen, 2 sophomore, and 4 junior. Find the probability the first 2 people selected a freshman, and the third one is so we need 3 people. So the probability in this case will be first 2 people selected a freshman. So will be the first 2 person. So it will be 2. Will be 1 out of 5. 2 out of 5. Yeah. Is that correct? See, it should be 2 out of 5. 2 out of 5 is better. So we have 5 freshmen. Something not right over here. So total we have 5. So total we have we need to know the sample space. So that total 11. So the first one will be 5, 11. The first fragment. The second one will be 14. Yeah. Right, because there's only 10 students, because you pick the first freshman. And the third one is junior. So junior there are 4. So 4 over 9. Yeah. Yeah. So over here you're gonna have with 80 over I don't know, 90 times 11. Put into the calculator. 990. The 80 divided by that. So about simplify, so A over 99. Okay, yeah. You need to calculate the sample space. I forgot, that's why I get stuck over here. Alright, example number 3. Okay. Find the probability of getting 3 heart. So probability this guy 3 heart. So how many heart we have over here? We have 13 heart over 52. Then the second heart will be 12 over 51 and 11 over 50. Okay. Then if you go ahead and put it into the calculator, you will see we end up with 11. Okay, put it into the calculator, guys. 850. Okay, so you go ahead, it's about 0.00129. There you go. So it's about 1.29%. This is 1.29%. It's not a lot, right? It's not a and believe me, they all the good gambler they use probability over here to win. Like you see in the first video where we talk about introduce the probability and talk about Arnold Rothstein. He used some way somehow he can apply the probability concept, or maybe he used intuition, but or his intuition is also based on the probability concept too, and it help him a lot with the victories where he win a lot of benefit, a lot of money from gambling. Okay. Now in the next video we'll be talking about another type of probability when we have a restriction. We call it conditional probability. But I think in this video I think that's good enough already. I'm gonna stop over here. Again, if you have any question or you spot any mistake, please let me know. Okay. But I'm sure I think 99.9% is correct. I'm not gonna go for perfection, but of course sometimes I have error, human error. But I'm sure that over here is 95%. Now at 99.9% is correct already. Okay, but if you can spot anything in a careless mistake, just let me know. Okay, I'll be seeing you next time.